everyone, it's Miss Sote. So we're just quickly going to finish up our last page of notes for homework. We did a bunch of examples today about choosing specific forms of our lines, point slope versus slope intercept. And now we're just going to kind of tie a few things together. So if you remember a few classes ago, I said that most lines are functions. But there are specific types of lines that aren't functions. And that's kind of what we're going to explore today with the vertical versus horizontal line. And remember, a vertical line is straight up and down. A horizontal line is side to side. A classmate recommended that he thinks of horizontal. He likes to focus on the part that says horizon. So if you think of a horizon at the ocean, that's really flat and side to side, whereas vertical, straight up and down. So we're going to focus on vertical lines first. And the really interesting thing about vertical lines is that their equation is not written like we would normally think a line equation is written. So in all of our line examples, we had y minus y1 equals something, and then y equals mx plus b. So y tended to be a prominent figure in the left side of our equation. But with vertical lines, we actually don't talk about y at all. So the way you write a vertical line is x equals, and then all that's going to be here is a single number. So x equals a single number. So for example, you might have x equals -7. And that's the entire equation for your line. And this is where our lines kind of stray from the function realm. So is this a function? This is not a function. And the reason would be is if you remember when we were talking about functions, we had something called the vertical line test, where if a vertical line hit our graph at 2 or more points, then that graph wasn't a function. Well, if you put a vertical line on top of a vertical line, you're going to hit infinite points at every given instant. So this is not a function because it does not pass the vertical line test. And let's think about this. So if I have a vertical line on an axis, let's say our vertical line is x equals 2. So when x equals 2, we just have a straight line at x equals 2. Well, y could be, so if x equals 2, then y equals 0, 1, 2, 3, -17, 58. Y could be every single value. And we'll show an example of a graph of an x equals value later. But if you have one value for x, any single value for y is possible. All you have to do is look at the graph. So vertical lines are definitely not functions. They break about every single aspect of a function that you could ever think of. And so that's our main example of a line that is not a function. Horizontal lines definitely are a little bit calmer. Horizontal lines are our side-to-side lines, and they're written a little bit more similarly to point slope or slope intercept because it starts with y equals, and then what you'll have here is a single number. So y equals a single number. So an example of this might be y equals 14. So vertical and horizontal lines are very, very basic forms of lines, so they don't really have much going on with their equations. And this one is a function, because if you think of a horizontal line, well, if I pass a vertical line through any point, you're only ever going to get one y value. So this is a function because every input only has one output. And remember, a function, it's totally fine if every single input has the same output. So let's put that in parentheses. Remember, it's okay if every input has the same output. So remember, the definition of a function is each input needs one output, but it does not matter if each input in our graph has the same output, which a horizontal line you would totally have. At x equals 2, y might be 3. At x equals 2,000, y would still be 3. So let's look at what this looks like. And we're going to just graph x equals -3 and y equals -3. And I'll choose 2 different colors so that you can see that a little bit better. So we'll do x equals -3 in green. And all you have to do when you plot a vertical line of x equals -3, go to our x-axis, find -3, all right, and you're just going to draw a straight line through x equals -3. So a straight-ish, sorry, this drawing tablet can sometimes be a little bit hard to draw straight lines with. So a straight line through -3. And now you can really see why this breaks the vertical line test. So at x equals -3, y is 1, 2, 3, 4, 5, 6, -1, -2, -3.5, 2.11. Every y value is possible with one x value. So that breaks our definition of a function completely. And then we'll do y equals -3 in pink. So for y equals -3, we go to our y-axis, we find -3, and again, we're going to draw a straight line through y equals -3. Well, that was slightly better, slightly more straight. So now you have an example of what a vertical line looks like graphed. You have an example of what an equation for it might look like. And then you have the same thing for horizontal lines. So hopefully this helps you understand these basic types of lines a little bit better. If you have any questions about any parts of these 3-page notes, please let me know. We can meet up for office hours. Other than that, have an awesome day.